some of you sleepy, so good to see some of you with a cup of tea or coffee. But we have a very, very interesting topic. And the moment I'll tell you the topic, all of you will be surprised that in a DevOps Asia Summit, what is the topic I'm talking about? The topic is a marriage made in heaven. How is that possible? Yes. Add on to that, we have Mr. Arun Narayanaswamy from Amadeus Labs, who will be talking on GitOps and Chaos Engineering. He is working as the Senior Director Engineering in Amadeus Lab. So let me take this pleasure in inviting Mr. Arun on the stage. Let's give him a good round of applause, all of you. And he will take you through the insightful journey of GitOps and Chaos Engineering. Over to you.
Thank you so much. Hi, everyone. Great to see you all here. The toughest session is always post-lunch, and thanks to all of you to have made it here post-lunch. Hopefully, the session is not going to put you to even more deep slumber, and let's try to make it more engaging. So thanks, Excellentro team, to have brought me here. So a little bit about me. I've been in various different engineering transformation roles across DevOps, cloud transformation. The recent most role has been running the developer experience team at Amadeus. I'll talk about Amadeus in a quick slide. I'll try to complete it and catch up on time. I know we are running late already, so I don't want to go deeper onto this. Oops. Okay, so why do I put the slide about my company is not about, obviously we are a product company, nothing related to DevOps, but we run the travel backend systems. So if you have ever walked into your Changi airport, the majority of the technology running in terms of baggage tag, your PNR, ticket generation, etc., all of that happens through our systems, right? So we run about more than 50% of the travel industry or the travel industry's technology is run by Amadeus. And why is it important? When you're running the airlines, the airports, the cruises, the hotels across the globe, you have to be resilient. We did about 1.5 billion passengers boarded just last year. Just getting out of pandemic, the scale of it is significant. And to build all of those, when we talk about systems like we did 10,000 deploys a minute, would you be happy if your airport or an aeroplane that you're sitting on gets upgraded while you're sitting on it? May not, right? So you have to be resilient, you have to be stable to ensure that you have a great traveler experience, right? So that drives a bit of we being prepared in terms of stability, resilience, etc. And my pitch here is if we are able to do it, I'm assuming most of you in your organization should be able to implement sort of the features or things that we employ in your organization. So this is sort of a funny story because late 2019, we hired a business continuity plan expert from the market, and we were in a conversation saying, what if this building gets shut down, right? So we were like having a big laugh saying, why would a building get shut down? Why would the electricity go away? I'm based out of India, where electricity problem exists, not as, you don't see that in Singapore, but in India, it's still a developing country. You do see power outages. And we were still planning saying, okay, if there is a power outage, what do we do, right? Can they work out of a different office? Can they work out of a different city? Just a few months later, COVID struck. And forget about building shutting down, a city shutting down, the whole world shut down, right? But were we prepared? As a technology company, travel industry was the biggest hit. But what really happened was the rapid change of transformation which happened during that time frame. For example, people wanted refunds. You had to convert a lot of passenger planes to cargo. You had to change some of the passenger planes to supply chain, enabling supply chain for medicines and food supplies, etc. Right? So how resilient were these technologies in employing that process. So a little bit of both. Chaos engineering talks about planning for bad times and being prepared for it. And more importantly, how does your software itself can take care of technology-related disruptions, right? So some of these were process-related disruptions. So the last thing that you want a customer to see on your website is something's wrong, right? That's the first trigger where you would really kick a customer out of your, from them being a customer to somebody else's customer, right? I was in retail industry as well. A 3-second delay in a checkout process, if you're on an Amazon or I don't know what other e-commerce sites you use here, but a 3-second delay in a checkout process, you lose this customer forever, right? So same thing could happen. So you're searching for plane tickets. Imagine how many times would you actually do the search before actually clicking the search button or buy button. The last minute, if this page shows up just before you hit the buy button, you've lost that customer, right? So this is one thing that you have to avoid. And obviously, when this is the final page, but there are a lot of things sitting behind which would get impacted because of it. So the key thing that I like about this quote here is you being prepared as a technology, as a process, is half the victory, right? And the rest is all other things taking over. So 2 concepts which I wanted to share here. One is GitOps and one is chaos engineering. And the bit here is about how you could leverage both of them to make great customer experience, great developer experience in your organization. So what's GitOps in one slide? This is more, GitOps is basically everything's code. Be your infrastructure, various parts of infrastructure, network, firewall, configuration, various workflows. I think we had a presentation here on Terraform. How could you codify everything that goes into an ecosystem completely in code, right? And that code could be on different Git repositories. And why Git specifically is you could run your pull request to trigger off some of your actions, right? In some of our applications, SRE does not even have access to production servers. So they have to go make a change in the code for it to be effective in the environment. They can't log into a server to do that change, right? So everything in and around having it as a code repository, in the code repository where everybody has visibility into, makes everything as code as one, which drives GitOps. So where all, it's code, tests, infrastructure, documentation, deployment, everything end to end. So what's GitOps in one slide? Git as a single source of truth. So there is no other changes. The developer can't say it works on my system, nor can the SRE go change on the production environment and say, oh, you deployed this, but then I had to make 5 more changes for it to work. None of that happens. Everything is on one source of single repository. And it's a single place to operate. You could trigger off your builds, you could trigger off your deployments, you could trigger off your whole pipeline using your Git as a single source. And all changes are observable and verifiable. I think we had a talk more in Manjunath from Gartner spoke about it. Observability is the key. Observability drives your business, right? So if you're able to track, monitor, manage everything that goes on in your system, that's where you bring in your GitOps methodology, right? So a little bit tech, but not really that deep. What does GitOps really mean? Is there is a desired state that you define in your code. Could be in various different formats. Obviously, if you're using Argo CD, a combination of YAML is used. Then you have an actual state, which is actual thing running on your production. So what really GitOps does is either through a pull request, either through a pull or push, depending on how you manage, you trigger off the desired state to reflect in your production. So it exactly replicates what is needed, what is defined in your configuration, right? So what this eventually gives you is set of integrity saying whatever is in the code is what is reflecting. If it doesn't match in various scenarios, it sort of rolls it back to the state which was best known state in the past and gives you an end-to-end consistency. And obviously when all of this is done, it improves your developers' efficiency and productivity as well. So, and why chaos engineering? So we shift gears from GitOps to chaos engineering. So in similar concept, what is chaos engineering? It's basically helping developers, and obviously in terms customers, get consistent, reliable solutions and reducing impact on your systems by hardening against failures, right? So what is hardening against failures is, again, what Manjunath from Gartner mentioned is experimenting and ensuring you know what could fail before your customer knows is what really drives that experimentation, and fixing your infrastructure in such a way that it works, right? I gave you an example of business continuity when I started this talk. How did we prepare? Did we have right backups in place? Did we have scalable VPN models where everybody could work from home? When things went bad, did we have good rollback plans in place, right? So all of them were automated and kept as systems or configurations in Git. So there is no dependency on a single person when things go wrong, right? So again, I think it's interesting. A lot of these topics revolve around similar concepts. I think there was a talk on talk earlier here, which talked about what is the cost of downtime. So a cost of downtime, a single minute cost of downtime on Amazon, based on revenues, assume their login page itself is down or your people are not able to place orders, is somewhere around 220 million, right? Similarly, e-commerce is one of the biggest impacted, but these are financial impacts, right? But think about it, if you are not prepared, not planned, if you're looking at an airline industry or an healthcare industry, and your lives could be at stake, and that cannot be equated in terms of financial money, right? The financial aspects. So what's the 4-step process of chaos engineering? Simple. You identify, there's a quadrant for chaos engineering. It basically is to say, if you are running an application, do you know what could go wrong? These are things like known knowns. There are known unknowns, unknown knowns, and unknown unknowns, right? So in terms of identifying what could go wrong and go through that process in a learning cycle, right? So you basically create a hypothesis saying, I have 3 load balancers. What if I bring down 1 load balancer, right? Do I know what is going to happen, whether the load is going to get shifted to the other load balancers? Will it manage efficiently? Will the application still work the way it is supposed to work? That's where you build the hypothesis in terms of what you want to test. The second phase is obviously to test the process. You actually bring down the system or whatever set of systems, saying you bring an EC2 instance down, you bring a load balancer down, you load the systems by X percentage, etc. It's a combination of all your unit testing, regression testing, performance testing, etc. Derive insights out of it and learn from it, right? The 4th phase is the most important. If you don't learn, there's no use experimenting, right? So that's the key thing in terms of insights. So how does the workflow happen? You plan an experiment, which is the most important bit. You know what needs to be done. Once that's done, start small. So if you have 3 load balancers, don't bring down all 3 and expect things to magically work. It won't, or unless you've built a resilient system underneath it, saying you have a passive instance sitting somewhere else, which has 3 more load balancers and can take over. So start small, measure the impact. If things go well, increase the blast radius. So when you bring down one load balancer, you know what is expected. What if you bring down 2? What if you bring down 3? And if you have a failover instance, does it really switch to that failover, right? One of the interesting examples that we faced was somebody checked in their password into a public GitHub repository, right? This was as a part of the code. When they were creating an environment, that code was checked into a public GitHub with the password of the production environment, right? Can you simulate it? So can you simulate it saying somebody does this? Do you know what mechanisms you need to employ in your ecosystem to say if something like that gets leaked, how do you quickly change passwords across your whole environment, and does your environment still work, right? What really happens is you change a password in one place, you figure out there are dependencies which stop working, and the system goes down, right? So one of the biggest things that we face when we see from security standpoint is changing password seems so simple, but it's not as easy when you say, I need to change all the 100 passwords touching production environment, right? So the final loop is important, is once you know what is going wrong, learn from it and increase the blast radius. So if you're doing scaling of 20%, increase to 40, increase to 60, and at some stage, it'll get to the phase of unknown unknowns. Is when you get to some stage, what is going to fail, you don't know, right? But as a company, as an organization, you need to know first before the customer knows it. So that's the whole process at the last in terms of getting through that learning cycle. So more of a logical view, which we touch upon when you have a chaos engine. Chaos engine is about talking about various aspects that need to be fixed. People, culture, and process. Most important, the business continuity plan that I was talking about. There's no automation behind the scenes. It's basically a written document or a process. What do we need to follow? Who do we need to talk to when things go wrong? Building that collaboration model within your group is very important. Applications, obviously, you employ Git, DevOps, and GitOps practices. Is automate everything. Your deployment process should be automated. You shift left, your testing practices should be automated. All of that is very important. And platform and infrastructure plays the third role. Everything on the infrastructure side, automated. When I say automation, nothing should be manual, in the sense somebody shouldn't log into a system to restart, somebody shouldn't log into a system to make a configuration change. If you build all of those practices in place, is where you get into the next cycle of saying, how do you benefit out of both these technologies that you have been using, right? So, which I call as the multiplier effect. Anyone here knows what a multiplier effect is? It's a concept of economics, which is an old-time thing. Maybe I can pass on the book. Somebody tells me what multiplier effect is. Sure. Okay, let's give one more chance to someone else, and then you're halfway there, but not really. Anyone? I can keep the book for myself. So, okay, let me take this. So when basically two technologies or a combination of technologies, I'll give it to you. So when combination of two or more accelerating technologies, right? So GitOps is a concept which is helping in infrastructure, automation, tracking, consistency, integrity, etc. And then you have chaos engineering, which is helping reliability. But both can be used independently. It's not like Agile and DevOps. Agile and DevOps too can be used independently. But the benefit of it is reaped when you combine both of these together, right? I can give you sort of an example which is very interesting. I think 2006 is when the whole world shifted from edge to 2G. 2007 is when I think Apple iPhone got released. 2008, 7-8 time frame is when cloud got released, and Google Maps came out in 2009, right? So series of interesting technologies and products. But what happened in 2009? Can anyone guess? A company which leveraged all of these four to transform the market. Another guess at a book? I have one, but I can find one more. Yeah, that's right. So Uber sort of leveraged all these four technologies, thank you. And Uber today, obviously it's sort of settled down, but one of the biggest disruptors in the taxi industry, owned nothing, but transformed and leveraged every technology here into the next level, right? So that sort of is the multiplier effect. Many of your organizations could be using cloud, combination of DevOps, Agile, etc., also to do the same. Right? So how do you manage chaos better, right? So this is the set of the marriage between the two, right? Collaboration improves when you bring in GitOps and chaos engineering together, right? So you're basically simulating attacks on your environment, seeing what really happens. And once you know that, you identify dependencies, right? So in your application, you could have an external dependency, a dependency into a small team within the group. You're able to pick that and simulate it when you do chaos engineering attacks. But what is even more important is it should not disrupt your ecosystem, right? So you are testing it right, and your GitOps ecosystem helps bring it up, bring back consistency into your application and not really impact the customer at the end. Scaling, obviously scaling on the cloud, which is a concept which is used by a GitOps and chaos engineering in some ways, where you are able to scale your environments, bring up new environments, quickly test things out, destroy it, and go back to your previous working state. Automation, GitOps drives automation. Chaos engineering leverages automation to ensure those testing is done accurately. And tools, right? I mean, the market is flooded with set of tools. We heard from a few of them, including GitLabs, GitHub, etc., which could be used in terms of managing this whole process end to end. So what benefits you get out of these two put together, right? So obviously streamlined operations. Your operation team knows what can go wrong because you have already simulated it. When things go, let's say if you're running Netflix and a new series of Stranger Things comes up, you know there's a spike in terms of the number of users who are going to log into the Netflix ecosystem, right? Has Netflix simulated it? In fact, chaos engineering comes from the Netflix ecosystem, where they leverage chaos engineering and Spinnaker together to drive or simulate issues at their end and fix it by knowing it behind the scenes, right? Improve developer experience, which is important. When you simulate, when you know things can go wrong, your teams are better prepared and can sleep in peace, saying, okay, even if there is scaling that is happening, you're able to manage it. Identify dependencies. I talked about it. When people are connecting across different ecosystems in the microservices world, this goes crazy. When you are able to simulate some attacks, you bring down certain set of microservices, what really happens? What if just the reporting microservice goes down? What if the login microservice goes down? In fact, a great example which came from Netflix is when you open Netflix, I'm assuming most of you have seen Netflix. Okay. There is a section which says movies you might love, right? What if that module goes away? Do you bring down the whole page, or you just pick some random and show it in the same place so that the customer doesn't feel that he or she is missing something, but the ecosystem knows there is something gone wrong and I need to fix. So the company knows it, but the customer doesn't, right? So that's something kind of a simulation that you need to do to be able to drive or identify these dependencies. Reliability obviously gets combined with both. If you don't have GitOps, your recovery or a rollback is going to take so long that your testing will cause more disruption than really getting benefited out of it. And end-to-end, the deployment being faster. So obviously, every marriage has something negative too. So what do you need to do in terms of ensuring, why do you struggle, right? So GitOps or chaos engineering does not work well if you don't have good observability, right? You need to ensure you have the best of tools, best of dashboards. And when I say best, it's not the most expensive one, but what drives KPIs for you, right? For some teams, it could be faster deployment, faster recovery. For somebody else, it could be something else. So mindset change, it's when you say all of this have to be done ideally in production. Chaos engineering, the most mature systems are systems which are doing chaos engineering on production. But go tell this to your CEO or to the product team saying, I'm going to test bringing down some applications. They may not have the cultural mindset to test it out, right? So that's most important. Risk on production, which is sort of extending onto it. And the most important is false confidence. Is you have tried, tested a lot of these things. You shouldn't build a false confidence saying, my application is now 100% resilient. If Amazon goes down, if Azure goes down, my system will still work. But there is always, any code you write will have bug in some way or format. And that's something you still may not know. This is a field of unknown unknowns. The more testing, experimentation you do, the closer you can get to some of these. So last slide, in terms of, are you ready? In terms of your team, your organization, you should have good observability practices, set of dashboards which are action-driven. You need to know what really could fail and how do you respond to it. And if things go bad, how quickly can you bring it back, which is the set of good maturity practices in terms of automation. Have a good plan in place, both roll forward, roll back, revert, whatever you want to call it, or have a backup system saying things go really bad, you have a system to bank on. And obviously try it on production, but be aware it could have a financial impact, it could have a impact in terms of life, as I said, in terms of healthcare or in terms of airlines. You don't want Airbus to be upgrading their pilot software when the flight is mid-air, right? So there are checks and balances, but be aware what is the extent that you can go with, right? That's me on this topic. Hopefully you took something out of it. Thanks for bringing me here. And if you have any questions, maybe I have a minute, I can help answer.
Any question? Okay, so we can call the winners on stage to receive the books. Congratulations. And I must say, okay, let us finish with this. So there were two of you. Okay, big round of applause for the winners. There was one more. Yes, please come. Congratulations. So, Arun, I must say your slides were wonderful and your voice, anybody will wake up. You know, so the energy with which you spoke, awesome. So I take pride on behalf of Excellent Row in felicitating you.